Welcome the grade 9s, and this is Mr. Ndabezita. Once again, one thing that I want us to look at this time is just some problems in grade 9. I have selected random problems for us to look at, and I think we will be studying sequence and series. Now in question 3 they say consider the following shapes and answer the questions that follows. So I'm not going to directly draw up the shapes, I'm just going to show you the numbers that are contained in these shapes. So the first shape has 5 squares, the second one it's 2 4 6 8 9, and the third one it's 3 6 9 12 30. Right, I think this is correct. Let me see. 3 6 9 12 13. Yes, so this is the first shape that we have, the second and the third, and a table has been provided to us. Of course, let me just show you how the table is drawn, so that we may at the end of the day understand what is happening here. So we have the shape, and we have a number of okay, they say they are rectangles. All right, so we have 1, we have 2, we have 3, we have 4, and so on, and we have R with 101 number there. So the first shape has 5 9 13, and this one it's Q. So in 3.1.1 they say refer to the table below and write down the values of Q and R, and they just provide 1 mark for that. Okay, that is fine. They want the value of Q and the value of R. So the most important thing is to know and identify the type of a pattern that we are dealing with. So let's just try to see what is happening here. 5 9 and 13. So what number can I add from 9 to get, what number can I add from 5 to get 9? That's 4. What can I add from 9 to get 13? I think it's also 4. Right, so meaning this is the constant number that we add in order to get the consecutive terms. So meaning I can write down the mathematical formula that can define this pattern, because it's linear, because you have the first constant difference. A linear pattern is defined by the mathematical equation Tn equals a plus d into n minus 1, where a is the value of the first term, that would be 5, and d is the constant difference, that would be 4, and n is the number of terms. So let me just substitute those ones very fast, and we can remove the brackets by multiplication in here. So you have 5 plus 4 times n is 4n, positive 4 times negative 1 it's negative 4. And these two are like terms, so I can say 5 minus 4, that is 1 plus 4n. So this is the mathematical formula that describes the behavior of the pattern that we have. Very good. So let me just zoom back a little bit. Very good. So what we are going to do is to find the value of T4. We want to know the term number 4, what value does it have? Because term number 1 has a value of 5, term number 3 has a value of 13. We want to know term number 4, what value it has. So you just say T, where you see n, this is the term number, equals, remember we have the formula 1 plus 4, but we are looking for the term number 4. Very important. So 1 plus 4 times 4 it's 16. So the term number 4 has a value of 17. This is very, very important that we try and understand that. Very good. So if we have, that is fantastic. So how do I find the value of R? Now see something here. R is the shape number, so I am given the value but I don't know which term number contains that value. So what do? You write down your equation. Tn equals 1 plus 4n. Therefore, you know the value of Tn. Remember, this is the value of Tn. Very, very important. It was 17, but this time we are given 101. So Tn is 101. Remember, this n is the term number. So I'm looking for the term number that contains a value of 101. Very important. Take this one to the other side. You are looking for the value of n. Divide everything by 4. 101 minus 1, it's 100 divided by 4. This into this would go once, and you can just go to your calculator in order to find out what the value here would be. Very, very important. Or you can even use long division in order to work that out. I'm not going to do that for you. So that was 3.1.1. So let's try and look at 3.1.2. So in 3.1.2 they say determine the general rule, which is Tn of the pattern. Fortunately, we have already done that, but we can repeat that since it is required. You start first by writing the mathematical equation that describes a linear pattern. A plus d n minus 1, where a is the value of the first term, d is the constant difference. And you know that when we work this out, we will get 1 plus 4n. And they are providing 2 marks for that. Very, very important. 2 marks are provided for that. Okay, that is fine. Let's not argue anymore with regard to this. I think now we can go to 3.1.3. Let's just go to 3.1.3. So let me just do this very quickly. So let's go to 3.1.3. Hence, determine which shape will have 205 rectangles. So they want us to determine which shape. So the term number that can contain 205 rectangles. So I know the formula. It's Tn equals 1 plus 4n. Let me just check. Yes. So they want to know the term number that has 205 rectangles. So it has a value of 205, and I want to know the term number that has that value. So take to the other side, divide both sides by 4. This into this will go once. 205 minus 1, it's 204 divided by 4. Plug this on your calculator and the answer will be provided for you. And then we are done with question 3.1. We go to 3.2. Right, 3.2, given the following number pattern. So we have 2, we have 5, we have 10 and 17, and it continues in that direction. And in 3.2.1 they say provide a rule to describe the relationship between the numbers in this number pattern. So they want a mathematical description, a rule that would define how the pattern behaves. Now let's look into this. We have 2, 5, 10, 17. What number should I add to 2 to get 5? 5 to get 10, and from 10 to get 17. Do you see what is happening? From 3 to get 5, from 5 to get 7. So we are dealing with what we call a quadratic number pattern. This is a quadratic number pattern. Now the question is, how do we go about doing this? This is quadratic, so I'm trying to find the easiest way of explaining this. So how about I say that Tn equals 2n squared plus let me check. Or what if we say n squared plus 1? Let's try to see if this would work. 1 squared is 1, 1 plus 1 is 2, 2 squared is 4, 4 plus 1 is 5, 3 squared is 9, 9 plus 1 is 10, and 4 squared it's 16 plus 1 it's 17. You see, it's a quadratic number pattern, but I'm trying to write it in a simpler way for a grade 9 learner, because in grade 9 they usually do not introduce a quadratic number pattern. But it would be very good for any grade 9 learner to know a quadratic. So I will deal with quadratics for grade 9. This would be for high grade, of course, for a grade 9 learner. So I will not deal with this. I will rather go for this one. So they said, remember, provide a rule to describe the relationship between the numbers in this number pattern. So the rule that would describe this would be this. This is the rule. This would be the mathematical rule. A rule can be a mathematical equation. It can be a wording that one can use in order to describe the behavior of a pattern. So for us, the rule would be Tn equals n squared plus 1. That would be the rule for us. So 3.2.2, meaning we have written the rule in terms of a mathematical equation. Use your rule to find the 10th term in this number pattern. So they want to know the 10th term, what value it has. So we have a formula, n squared plus 1. So T10 will be 10 squared plus 1. That would be 100 plus 1, which is 101. So the 10th term has a value of 101. This is exactly what the rule says. So by the time you arrive to the 10th term, you would find that the value is 101. Because I know T1 has a value of 5, T2 has a value of, T1 has a value of 2, T2 a value of 5, T4 a value of 17. So by the time you reach the 10th term, you would find that it has a value of 101. I hope this is making some sense. Alright, let's continue in this and see how far we can go. Right, what I will do in 3 point, let me check. We are from 3.2.2 we go to 3.3. So in 3.3 they say read the flow diagram below and answer the questions that follows. So they have provided us with something like this, and this is 1/2 x plus 2, and we have the following values. We have -2, 0, and b. We have a, 2, and 4. So they say in 3.3.1 they say what is the output value in a. So we have the input. This is the value that you substitute where you see x. You add 2 in order to get a, because this is the input part, this is the output part. So you take your -2, where you see x, you put in that value plus 2, you get a. So let's try and see how that works. So let's write down first the mathematical description. 1/2, where we see x, let's write down -2 plus 2, and this must give us the value of a. If you go to your calculator, 1/2 times -2, this into this goes once, you are left with -1 plus 2 equals a. So 1 equals a. But you can just put this on a calculator, it will provide you with that. And then in 3.3.2 They say, what is the input value in B? The input value. So meaning where we see X, we will be writing B. So we're going to say 1/2 B because that is the input value. Just as we inputted -2 in here. So I'm going to add 2 to this, and remember what the output is. The output is 4. Very good. So you will have your 1/2 B plus 2 equals 4. These are like terms. Take this to the other side. 1/2 B, 4. When this number goes to the other side, it becomes negative. Very good. And you will have 1/2 B equals 2. You want to get rid of the denominator, you multiply both sides by the denominator. Numerator, denominator goes once. 1 times B, it's B. 2 times 2 is 4. That's how you find your values. Very good. Now that we have done that, we go to 3.4. Use the table below to answer the questions that follows. So we are provided with another table. Alright, let me just see what is happening here. This is what we have. X and Y -3 -2 -1 0. We have this. We have Q and 8 here. Here we have -10, -7, -4, -1. Right. In 3.4.1 we have the following. Find the rule in the form y equals something. So how do we find the rule? Right, when x is -3, y it's -10, -2, -7, -1, -4, 0, -1. So let's see what is happening in y. So we have -10, -7, -4, and -1. Let's see what is happening here. I know that -10 plus 3 is -7. -7 plus 3 is -4, and -4 plus 3 is -1. So this is the constant number that is being added here. Okay, that is fine. So the rule for 3.4.1, it would be y is equals to a plus d into n minus 1, because it is a linear pattern. It's a constant difference. And the value of a would be -10 plus the difference would be 3 into n minus 1. Very good. -10 plus multiply 3n multiply 3 times -1 is -3. Group the like terms. -10 minus 3 is -13 plus 3n. So this would be the mathematical equation that describes the behavior of the y corresponding values of x. And then when that is done in 3.4.1, we go to 3.4.2. They say determine the value of q. Right, remember we are looking for the term number that is a value of 8. So remember we are saying that y equals -13 plus 3n. And what is it that we are looking for? The term number with a value of 8. So 8 becomes our tn, or our y value. We have the y value of 8. So we're going to write 8 minus 13 plus 3n. Take this to the other side. Equals 3n. What is 8 plus 13? That should give us 21. Divide all sides. 3, 6, 9, 12, 15, 18, 21. That should give us 7. This into this goes once. So term number 7 has a value of 8. Very important. Term number 7 has a value of 8. And we are done. Let's go to 3.5. And in 3.5 they say a straight line graph is defined by the mathematical equation y equals minus x plus 3. This is a straight line. The straight line that is defined by the mathematical equation y equals mx plus c. So where the value of m is the gradient is minus 1, and where c is the value of the y-intercept, our y-intercept is positive 3. But I'm not dealing with the graphs for now. We will deal with the graphs at a later stage. Please do not forget to like, share and subscribe to the fundamentals of Papa Fanzo. Alright, in 3.5.1 they say determine the x-intercept of the graph. So for x-intercept, that's where, let me just show you this. This is x and y, so this is what we call the x-intercept. Where you intersect the x-axis, the value of y has to be 0. Along this line, x is 0 in fact. So we are going to say x-intercept, in this line y is 0. X-intercept y equals 0. So we're going to put 0 where we see y in this equation. So I'm going to say 0 equals minus x plus 3. Take this to the other side. Your x equals 3. So this would be your x-intercept. When x is 3, y is 0. Because you are intersecting exactly the x-axis. Every y value along this line has to be 0. But I will explain this fundamentally when we are there. So 3.5.2, they say draw the graph showing all your intercepts with the axes. Use annexure A. We don't have that, and 3 marks are provided. So in order to draw the graph, a straight line graph, we need the x-intercept as well as the y-intercept. So let's go and find the y-intercept. So y-intercept, x equals to 0. Y equals, so where we see x, we write in 0 plus 3, which is 3. So when x is 0, y is a 3. Very important. So let's draw the graph. So this is your x-axis, this is your y-axis. From here moving that side, x is positive. Here moving that side, x is negative. Y positive, y negative. So what I can just simply do, I know I have x-intercept when x is 3, y is 0. That's the first point. When x is 0, y is 3. That's the second point. Join those two. Show that the graph is continuous from negative infinities to positive infinity. You might want to go and look at my university lecture where I deal with functions. I explain thoroughly the domain and the ranges of these functions. So if you're interested, a learner that learns out of the box, you might want to look at that university content. Right, that is fine. We are done in question 3.5.2. And where else are we going? Let me just check for you. I think we are done. Let me just go and look for something else. Right, I think I have found something else. This one, it's a graphical representation, and I will not be able to share this with you because I cannot draw exactly that which is drawn there. So let me just rather go and look for something else. Okay, let me go back. No, I think we are done for now. I think we are done for now, guys, and I will see you in the next lecture. I'll prepare something for you. If you subscribe to this channel, click the notification. Every time a tutorial is posted, you will be notified. Thanks a lot for your time.